Ladies and gentlemen, please welcome on stage, Katharina Kramer, Communication and Event Manager. AVERE.
Thank you, and welcome to the last session of this year's AEC. So we're going to be talking about creating circular vehicles and batteries, which is fitting with the name. We're going full circle in the last session here. So today we will be looking at the long-term potential of both vehicles and batteries. As the e-mobility ecosystem is developing, we want to stay committed to our sustainability goals, also in terms of what that means for components and products from their useful life cycle, at the end of their useful life cycle. So of course we're familiar with recycling in our everyday life, and it's a process that has really been ingrained in us. So this begs the question, how can we transform this, ingrained process into the automotive and battery industries? So the question, the central one, is how can we minimize waste while maximizing resources? So to answer this question and many others, we have a great panel with us today. And how it will be organized is that each panelist will have a presentation, then we'll have a discussion, and at the end, a Q&A. So already looking forward to your questions. So to start, I welcome to the stage Ilai Bendavid. He's the Government Affairs for BOTREE Recycling Technologies.
Hello, everyone. The clicker, it's there. Hello, everyone. So my name is Ilai. I have a background in economics and environmental policy, and I'm here to, first of all, present the topic of battery recycling, and then explain what our company does to enable this. So, as an introduction, I wanted to say that batteries are one of the most critical components to make sustainability happen, and they are the real enabler to renewable energy. But the issue is that, are they really sustainable as of today? How do we help this industry create real CO2 reduction, and how can we make the enabler to renewable energy really renewable? So CO2 greenhouse gases emissions really happen through the mining, refining, battery material, battery manufacturing, and also through the battery use. But what happens to them when they're at the end of their life? So BOTREE is here to enable this. So we sell our technology to the recyclers to create a real circular economy around batteries. So that's our business case. We have technology that's hydrometallurgical to extract all the critical materials from the batteries to reuse them either in batteries or in other fields. So I think that we can't ignore the carbon emissions of lithium-ion batteries. As of today, batteries really create 0.2% of the global emissions, but by 2040 we may reach, like the whole industry may contribute to close to 5% of the global greenhouse gas emissions. For an industry that's supposed to enable lower carbon emissions, that's a big number. So that's why this industry, more than others, is really expected to work towards reducing those carbon emissions. The car industry, like cars such as the Volvo EX30, they have close to 50% of their emissions that are made from the batteries. So recycling them can reduce up to 30% of their carbon emissions over the whole life cycle, which is a big number. We're also expecting to have the first big wave of end-of-life batteries to arrive around 2030, and as of today, we're not really ready to deal with them. So the whole industry has to get ready to deal with them, because today we don't, especially in Europe, we don't have the capacity to recycle them or to have the whole supply chains to reuse them, etc. So all kinds of battery production facilities are getting built today in Europe. Same for recycling projects in Europe. They're mainly been announced. Not all of them, or almost none of them, are built yet. It's the same in North America. But what's important, and we have really really big targets coming up by 2027, 2031. One for efficiencies, but also for recovery of the materials. So by 2027, the targets are to recover 90% of copper, cobalt, and 50% of lithium and 90% of nickel. That's the target. I don't think we have the capacity or enough projected capacity to reach those targets by then. This is why I'm here to talk to you, everyone, because I want to stress the importance of the regulations to also push for the investments to reach those targets. To conclude about explaining this topic, I want to stress again that battery recycling is a real effective way to reduce the carbon footprint of batteries, and so by at least 30%, which are also the key enabler to reducing carbon footprint across all kinds of industries. So how does battery recycling work? The first step of battery recycling is to create black mass. So it's mainly a mechanical process with also some furnacing to remove some of the electrolyte, for example. The whole process works through all kinds of levels of crushing and so on, where at the end we receive black mass, which is a big powder with all kinds of material in it. We can extract through the first step also copper and aluminum powder. BOTREE offers a technology, so two ways to deal with this. The first one is to have a mobile factory that can be put in a container and moving the factory to the batteries so that the batteries don't have to be shipped, which is a fire hazard. Or we have a centralized treatment plant that can be sold to our partners to create this black mass. The second step is a hydrometallurgical step, to take this black mass and remove each of the key components. So each battery chemistry has different ways of doing it. So for NMC batteries, we have a lithium first extraction method that through different leaching and impurity removals, we can get a high purity lithium solution and nickel, cobalt alloys and salts. We can get up to 95% of lithium recovery rate and enough purity so that it can be reused into batteries. For the nickel and cobalt alloys, we work with different partners who can also separate them and also have enough purity so that it can also be used into new batteries later on. So that's one of our pilot factories for NMC battery recycling. For LFP is a bit different, mainly because there's not as much critical material that can be recycled. Iron phosphate is not extremely expensive, but we have also lithium first extraction in which we can remove the lithium from the batteries. Also at a 95% recovery rate and at a battery grade quality. So that's our pilot plant for LFP recycling. So all our equipment is CE rated, which really helps with the permitting phase. Additionally, they are skid mounted, so they come on different containers and they're connected with each other which the whole process is very fast to build. We can get it up and running in less than a year if all the permits are already received and the factory is already built beforehand. We also have services in carbon footprint assessment and also different other consultancies to help with the economic side of things with our different customers. So we have, across our 4 divisions, we have worked in more than 10 countries, over 45 projects across the world. So that's we have 1 factory in the US, 1 factory in Spain. We're working on a bigger project on our own in Gubern in Germany. We have worked with production scraps in China, a pilot line for NMC in Poland, and we're working on more projects that are yet to be announced as well. So BOTREE is a Chinese company. They're based in Suzhou, next to Shanghai. We have over 120 intellectual property applications, more than 30 patents, and we published a number of research books with publishers such as Wiley. We're collaborating with all kinds of global organizations such as the GBA on the battery passport, on the ISO committee on lithium to create standards for lithium. And we're also working on 2 new books. So one is on battery swapping and sustainable transportation. And I'm also personally working on the battery passport book, all on Wiley, to help the industry move forward. Thank you for listening to me. And
Thank you, Ilai, and also for providing us for behind the scenes of a battery recycling plant. Always good to find out about that. Next in line, we have John Mortell, who's the Senior Policy Manager at Plastics Europe. The floor is yours.
Marvelous. Back to having the slides. So, thank you all. My name is John Mortell. I'm a Senior Policy Manager at Plastics Europe. We are a European, Brussels-based trade association with several regional offices, particularly France, Germany, the UK, Spain, as well as Poland. We are the plastic suppliers of Europe, so we are a lot of companies that you will very much recognize. Many of the members here that you can see on the board are obviously household names, and we're very active in terms of production of plastics within Europe and sort of the supply into various different applications. What I want to talk particularly today about is the end-of-life vehicle proposal, but also a little bit about Plastics Europe and sustainability and where we've been going as an industry, and for us what we consider to be the most key elements of this proposal, but also the importance of it when you talk about automotive and more general plastic sustainability. Where are we in the current EU regulation? We've seen over the last several years a lot of European legislation on all aspects of plastics, and the focus is really on plastics waste, plastics in the environment, but also the production, the safety, the chemical safety, the circularity, the material security. So as we've seen over the last few years with things like COVID, with things like the Suez Canal blockage, how we in a European production are able to ensure the security of our supply. We've also seen within the European Commission and with other regulators, so that at a national level, if you look at the French government, for example, quite a lot of activity on rules specifically around plastics and safety of plastics. So started with packaging, which is roughly speaking about 40% of European plastics production and usage, moving towards automotive, which is about 20%, and eventually building and construction. So we have a lot of the major applications, a lot of rules coming in, but also a lot of questions and elements about the design. To that end, we now have a European Commission proposal on the end-of-life vehicles. So how are we making our cars? How are we designing them? And how are we designing them so that when it comes for time of recycling them, what does that look like? For the plastics industry, the key element is that we have a 25% recycled content proposal on all new vehicles. Obviously, timing is a little bit difficult when we're talking about an active proposal, but essentially those cars that will be entering into the market in 2032, 2033, based off the current proposal, should have 25% recycled plastics, and of that 25%, so 6.25%, a closed loop material, i.e. material that came from other vehicles and went back into new cars. And that's across all vehicles that would start to hit the market at that point. Obviously, that's a very ambitious proposal, and we have some questions about how feasible it is, how the Commission looks at doing it. But there's also other elements in there, so particularly design requirements, so design for simplification, how you make vehicles more dismantleable, how you allow, so for example, as I'm here at an e-mobility conference, talking a lot about how can you remove the batteries? How does that work? How can you make it easier? Is it what you want? What are the impacts of that on things like safety, performance? How workable is it? Extended producer responsibility as well being a big element, so who is responsible for what and where in the value chain? So when we talk about plastics waste collection, we see that there's still a lot to do, and that a lot of the collection is not great. And particularly when you look at the automotive segment on there, it's not exactly very impressive compared to some of the other areas. And so what we're looking at today when you start talking about a recycled content target and redesign of how you get the plastics from a car, it's going to be quite an uphill struggle if you're talking about something that wants to be there in 6 to 7 years. Of the automotive plastics that are collected at the moment, a lot of it goes to landfill and energy recovery, which is obviously not ideal. We can say as a positive that the collection has started to increase across the industry, but again, when we talk about the overall sustainability of vehicles across their life cycle, so not just the production, not just the use phase, but also what you do at the end of life, we see that a lot of that at the moment just ends up essentially as waste, or at best as energy recovery, but not as a material, if we take the previous speaker, not as a material that you can turn around and put back into the European market, put back into the production cycle. So when we talk about it as Plastics Europe, we're looking at something to how we can increase that, how we can improve that. And particularly for us, there's a couple of key elements on there. We have, in particular, the value of open loops. What we see right now is a lot of plastics that is collected from automotive often ends up in other applications, but also that material collected from packaging, for example, ends up in automotive plastics. Car seats are usually the traditional example that is the simplest one. How do you do that? How do you do that if you have a closed loop system? But also, how do you do that when the first rules on plastic circularity in Europe are about packaging? For a lot of the automotive industry right now, when I talk to different parts of the industry, they will say, oh, but we can meet this by getting packaging materials. Can you, if in next year you're supposed to have rules that require you to have 40% circularity targets for plastic bottles? Quite possible that you're going to see quite considerable shortages very quickly. So what does that look like in terms of this type of material, and what kind of materials can we do? For us as Plastics Europe, therefore, we are supportive of the proposal, but what we're talking about is how you get there. So one element of that is chemical recycling, a technology that takes a lot of those very hard to recycle plastics, breaks them down into their component parts, and allows new material. It is a new technology, and again, when we talk about investments and investment certainty in Europe, we do not see a lot of that currently where it needs to be in terms of acceptance of the technology. Inclusion of bio-based plastics, so materials that are made from bio-sourced feedstocks. That can be often also waste products. Friteur oil being probably the classic example of something that you can take as waste and turn into something that can be very useful. But also we need more recycling. We need investments in recycling companies. We need much more investment in the recycling industry in Europe. Something that right now, as many of you see in the news, of course, is not necessarily the case, where we see an environmental and economic circumstances that are moving in quite divergent situations, where the environmental demands are increasing and those require investment. But in many cases, the companies that need to make those investments are looking at a not particularly favorable economic outlook. And so what we see right now is how can we bridge those gaps? From our perspective, of course, we see it as an opportunity rather than as a negative, particularly if you take recycling and new plastics. It gets industry working again within Europe. So again, when you're talking about sustainability and the more general political environment that we're in right now, shorter supply chains, more material kept within geographical locations, and recycled content as a way to help doing that. So for us, we see that as probably the key element. We have been very engaged with the wider sector on this. And so for us, it's very much that we would like to see that this proposal is supported across the industry, that we would see that over the next 6 months to a year, where this proposal will move through the Council and Parliament, so the two co-legislators at the EU level, that we have an ambitious target. Of course, we know that for many parts of the automotive industry, the concerns will always be not only the price, but the security of the supply and the quality. And again, when we're talking about sustainability, and particularly sustainability in a European context and investments in the European economy, we see that there is a need to be ambitious in order to create those circumstances. That's obviously not necessarily straightforward or easy, and as I say, especially in the current economic and political climate, but it is something that we feel is very important. Just that for a very short element, why are we as the plastics industry? I think for a lot of people it's quite surprising that the plastics industry is the one talking about this. We have over the last few years seen much pressure put on us as a sector in terms of our societal value, where we're coming from, how our materials are used. So we as a sector have created a couple of different papers. Breaking the Plastics Wave was the start, Reshaping Plastics, and now the Plastics Transition. And what it talks about is an overall approach to European plastics industry that says if we want a plastics industry in Europe, both from a societal acceptance, but also from a performance acceptance, so an economically viable plastics industry in Europe, we really need to see a change in terms of how we think of the value of our material. Plastics is there is a lot that plastics does for circularity, for climate protection, for investment, but that much of that value is not seen, especially when a lot of it is seen as disposable or as short-term materials. That's very different from somewhere like the automotive sector, where it's a material that will last for 20, 30, 40 years. But when we talk about it in terms of societal views, go to your grandmother, go to your neighbor, go to your cousin and ask them what they think a plastic is, they will often say a Coke bottle. The way that they think about the materials are quite different. We do see a need for mitigation measures in terms of improving our environmental performance, and that is something, again, for that societal acceptance. But that often requires investments in new and different technologies, your recycling, your bio-based plastics, your chemical recycling. But there is no one silver bullet. It's about bringing all different parts of the value chain in and how we can get there. So what we see now is a very kind of core vision for different levels. And I say we spent the last 5 years really working with the packaging industry on this. We're now trying to get the automotive industry in on side. And next will be the construction industry. But it's a core vision of to make plastic circular through investments, through change and acceptance of new technologies, through improved design requirements and improved material sourcing, and the overall circularity, and to lower the carbon emissions of it there. So what we would like to see by 2050, and that's in some ways these are long-term visions, and in other ways much of what we're talking about by the time you make the investments and get the technology on side will actually pass quite quickly. We would like to see about 65% of the plastics that would be used across all of the major users to come from circular feedstock. That's recycled content, whether it's mechanical or chemical, or bio-based materials. That we would see that biomaterials for plastics would double in growth over the next 20 years, and that we would reduce the CO2 emissions through circular feedstocks and also avoided waste and incineration. Much of the materials right now are simply just lost, particularly when we talk about sections like the automotive sector. A car that's been sitting outside for 20 years, wind, rain, sun, damage from other impacts, the quality and the material performance, it has lasted quite a long while, but what you can use it for in the next thing is often very unclear. And how we can move away from that is a big part. So we see basically that this is the first time that we've managed to get a certain amount of the plastics industry to come together, also to get many of our partners involved. And when we talk about that from a circularity perspective, it's going to be quite a big change in terms of how we think about our plastics industry. Finally, what we would like to see with this is that there's no one silver bullet. It's a mixture of different technologies. It's a transformation involving lots of different partners. So again, it's a transformation getting recyclers to be successful and to continue to grow in Europe. It's a transformation that recognizes the value of having European industry for plastics production, something that's not always seen by many countries. Some member states, and particularly parts of the European Commission, often view plastics production in Europe as a kind of a negative, when in fact the outcome would not be that you would use less plastics, it would just be that you would source more of it from North America, China, or other countries. Circular feedstocks and the growth there being a major point, and then an enabling framework, so a demand for recycled content across all these different major users in order to grow that. For the automotive sector, we see that the Commission is very much targeting automotive plastics and the production of automotive plastics as a big part of this legislation. We see that at the same time, they don't necessarily see the value of those plastics and how those work together. But we see an opportunity to help transform the European automotive industry, at least that part of it that is using plastics, in terms of its circularity and to help reduce the overall CO2. And that is our conclusion. So thank you very much, and I will let you on to the next person.
Thank you, John. Very important message about bridging the gap between the economy and and the environment, and also an important message to, or a reminder rather, to join forces with like-minded associations and partners to really stay on course and to repeat the message until it becomes cemented. So thank you for that. And I pass over to our last speaker, Linda Olofsson, who is the director of the Swedish Electromobility Center.
So, hello. My name is Linda Olofsson, and I'm director of the Swedish Electromobility Center. And today, let's see if I have a presentation here. Yeah, there it is. So I come from another perspective. I come from the research part, and I will try to tell you what we are doing in our center with research related to recyclability and to sustainability, and also try to show how we can use this triple helix platform that we are to look at what we need to do in the future. And in the end, I will also give a short commercial for the upcoming EVS38 that's happening in our hometown, Göteborg. So let's start. Well, just to give you a brief what the Swedish Electromobility Center is the National Research Center for Electrification of Transport in Sweden. And it's a joint investment in research between the industry. We have a strong automotive industry in Sweden, and academia, strong academia as well, and the Swedish Energy Agency that's investing quite a lot in it's like 300 million Swedish crowns for research. And we use that I mean, our vision, and I think we share it with most of you here, is that electromobility will be a substantial part of the sustainable transport of tomorrow. So our role is to accelerate that development, and to do so by actually looking at the whole value chain and making that sustainable, and at the same time also contributing to the competitiveness of the Swedish industry, of course. So our research is actually focused on 5 strategic research areas, and this center has been grown since 2007. If you look at the history, what happened in the beginning is that we had to learn how to solve the technology behind this electrification of transport. We needed to look at the vehicle. And so our first 3 research areas are devoted to the electric vehicle, the intelligent vehicles and systems, where we look at the thermal management and how to treat the battery in an optimal way to make it live longer, which is important from a recyclability point of view. We also have the electric drives and charging, and I will get into why it's important to look also at recycling of the electric motor. And then we have the energy storage, the battery, that we already heard from Ilai, the importance of recycling, and also prolonging the lifetime. And as this area has grown and the technology has matured, we have learned that we have to look at the systems surrounding the vehicle. So we have to look at the environmental impact of it, because using an electric vehicle is decoupling from fossil energy. We have the possibility to actually transport without using fossil energy. But it's just the decoupling. If we don't look at the whole system, we will not be fossil-free. So we need to look at that. And we also need to look at how society adapts to the technology. And I think, as you, John, said, we had like a backlash at the moment, and therefore we need to understand the users and how we can get this up running smoothly again, the adoption of EV technology. So yeah, we're working on that. And then we have the vehicle-to-grid interaction, and there were also some sessions here earlier on that, and how we can smart charging, and also how can we, in some countries, we have built a grid that's packed already with other industrial applications. How can we fit the electric vehicles into that grid and actually make them support the grid? So these are things we are looking at in the strategic research areas. So just to give you a little idea of what we are actually working on. So we, as I mentioned, we have quite a lot of money to spend on research projects, and we have like 60 research projects in our project portfolio that we are funding at the moment, and then we're also associating projects that we think are interesting, so we're like 40 associated projects, so like 100 projects that are in our portfolio at the moment. And we are looking into different aspects. These are just some of the aspects that's related to recyclability and sustainability. And what I want to lift here is actually, we have quite a number of projects related to the electrical machine, because we have already seen that we are working on recyclability on batteries and on plastics, etc. But it seems that the electric machine, not many people have looked into it. And what happens when the car ends its life is scrapped together, pressed, and no recycling of anything with the motor. So we are looking into how can we actually design the electric motor so that it's easy to remove it and to recycle the part of it, because it's some really important material in it. And then we also look into, because at the moment, the electric machines with the highest energy density are based on rare earth elements for the magnetic features. So we want to remove that, because the mining of rare earth elements is dirty and it's hard to recover. So we're looking into how to make electric machines with high energy density without rare earth metals. For example, by basing them on ferrite, which is actually something that we get from iron industry in Sweden, a residue, actually. Then we are also looking into batteries, of course, and how we can make them resource effectively. We're looking into the aging, because as I already said, it's very important from a life cycle assessment point of view, how long you can actually have the battery in its first application, and then if you can have it in a second application. So the longer it runs, the better for saving energy and material. We're also researching the battery management system, which is a way of optimally treating the battery during its lifetime to make it live longer. And and we are looking into many different aspects of life cycle assessment of the whole system, I must say. I just ran up a few of them here. We're looking into battery production and recycling and the vehicle-to-grid application, charging infrastructure, and electric motors. And so if you are interested in any of these, you could go to our website, electromobilitycenter.se, and we have all our roadmaps there and our annual reports to study. So what I wanted to tell you about is also that in this center, we have this strong automotive industry of Sweden represented, and they're very engaged. And we also have very strong academic partners. And we have the governmental agencies. So we are trying to utilize this platform and the people involved. It's like the creme de la creme of experts in Sweden, to actually look forward. What do we need to do to make full-scale implementation of electrification of transport? And so we have been running this work on a full overarching roadmap. So we have roadmaps for all our strategic research areas, but this we have an overarching that we were working on with workshops with all these experts. And in this work, we also looked at what are the milestones ahead of us. What do we need to really make happen the next coming years for the large-scale implementation of electromobility. So I just wanted to just briefly mention some of this, and then I will submit an abstract for the EVS38, and we will present some more of that work in that conference. So another commercial for that event. Sorry. But just to give you a brief... I have the Plastic Europe logo. Well, anyway, I don't mind. So when we work with these milestones, we were in the workshops with like 60 experts and working like broadly defining what needs to happen and then narrowing down what is really crucial and what is the timeline for this. And we could see that there were like 3 different areas that related to these milestones. It was vehicles, infrastructure, and production. And so today I will go in a little bit into the vehicle part because it's mostly related to the topic we will have in the panel. So if you look at the vehicles, we could tear the milestones down into 4 categories. The first one was affordable EVs, and that is that we need to make this technology be available for more people, not just the people that want to buy something even though it is expensive because you want to be sustainable or you think that electromobility is cool. We need to make this accessible for all people that need mobility. And the second thing was reliable EVs. And that is that we have to be able to rely on the components and extend the components' lifetime of the vehicle, and also make sure that it works in extreme temperatures, for example, or rough environments. And then it comes down to the resource-effective EVs and the recyclable EVs, and you see what we need are incentives and regulations that can actually push forward, that we actually go into designing and planning for recyclability and for sustainability. And the interesting thing, if you go further on and look at the time scale of this, you see what happens is that for affordable EVs and reliable EVs, we're on the way. It's already happening. I think we will finish by 2035. But when it comes to resource-effective EVs and recyclable EVs, you see what our expert thinks is 2050. And this we need to do something about, right? So that's my, I think that's my main message actually. So just some reflections before I give you the short movie. I think this will take time unless we do something and engage. And we're not as good as we think. We need to design and plan for recyclability. Because at the moment we design for cars, for example, to look cool, and then the engineers have to squeeze the technology in wherever it fits. And so there are different solutions for all the different models, which makes it very hard to dismantle. It has to be done manually, which costs a lot. So we need modularity so that we can exchange models in the system to make it live longer. And that is to extend the lifetime. That's very important. So, I don't know. How do I do this?
I think it will cover in Sweden the entire value chain. We have battery production, we have vehicle production, we know recycling, we know also a lot of the problems on system level and society. We have also a very high degree of electrification, both in our grids but also in our vehicle fleet today. We are actually forerunners in electromobility.
There's close cooperation between the industry academy and society. And that's a bit different than compared to Germany or US, for example. They have extremely good, of course, cooperation. But here I can also feel that it's kind of joint forces.
We have strong companies that are also driving the development with the combination of a good electric system where we have a lot of renewables. So in Sweden it's a good benefit to do electrification for transport due to these two synergetic effects.
I'm particularly interested in see the energy storage components and its integration into the vehicle. This I'm really looking forward to. New battery chemistries, but also fuel cell solutions, and how they will be implemented in different types of vehicles. I think this is what will accelerate the area.
Definitely networking on top of all the technical side. I think when it comes to the technical side is also charging. This has happened a lot, especially on the trucks side of things with the mega charging systems. So that I'm also looking forward to see something about.
So I think I'm looking forward to meet new people, to increase my network, and also learn from others.
Yeah, so these nice people you will meet in Gothenburg in the summer if you come. Hope you will. Thank you.
Thank you, Linda. And yeah, I think we mirror your message. Let's do something. Let's stay on course. And yeah, and of course, come to EVS. Also important message for today. I invite the rest of the panel on stage.
I'm not sure about the background.
So lots of things to cover, but perhaps to start from policy side. So obviously we have innovation, we have competition, but this has to be mirrored and cemented in legislation. And as we know, there are a couple of or a number of portfolios that are either being currently discussed, developed, or already finalized by the EU institutions. So Ilai, how do you assess the feasibility of the EU battery regulation together with its delegated acts and the Critical Raw Materials Act?
Well, I would say it's feasible, if that's the question of the simple answer to this question. The more complicated answer would be it's going to be feasible, but is it going to be happening on time? Are we going to reach the targets on time? I don't think so, especially as was previously mentioned, that all those targets are very, very ambitious. And as of today, we're not ready, and we're not as ready as we think we are. So all those targets, they're feasible, but not if we don't wake up and put the investments that are needed. And the issue also is nobody wants to be the first person to invest and to prove that it's possible. And we need to provide incentives to be the first to invest, the trailblazers in this industry.
Yeah, makes sense. So yeah, Linda, you also mentioned in your presentation the timeline and how it's of critical value to really stay on these demands. I guess that ties in a bit as well with the subject of competition. So obviously we're looking at competition from both the United States and from Asia. What can you tell us a bit about where we are right now in Europe, also from the research side?
Concerning competition, I think if you look at the battery part and research, I think we have a lot to do with the scale up. For example, if we look at Northvolt, you see that the quality going from small laboratory production to scaling up, you have a lot of quality issues. So you have to waste a lot of things. And so I think what we need to do there is to gain experience, and to do that we need competence. So we need a lot of engineers and people who understands actually how these things are working to figure out the quality issues. And this will of course take time and require quite some financing. And then I think on another level, when it comes to competition, we discussed about competence, and we also discussed the thing that we do have a lot of educational programs, for example, in Sweden. However, we have a hard time filling them with students, because our students seem to be interested in something else, maybe. And so I think what we need to do, and I think I come from Sweden, and we are sort of this country of engineers, engineering culture, strong engineering culture, and we are doing quite well on innovation point of view. And I think if we are struggling, then the rest of Europe is probably also struggling to get all these bright minds into engineering. And I think we need to do that. We need to make people realize that being an engineer is very cool.
Yeah, indeed.
And that requires us to start early, because these young people, they start very early to choosing their path in life. So yeah, and also we need to reskill a lot of people that we already have in our workforce.
Yeah, you're touching upon an important subject as well, of course, on skills. And as the e-mobility ecosystem is growing and developing, there will be new jobs, new positions to fill in future. So are there already programs in place that you could mention that are interesting, not just in Sweden, but maybe on the European level as well?
Yeah, I'm mostly familiar with what's going on in Sweden, and I know that we have several programs starting now for just electromobility and the different aspects. And so the problem is not that we don't have the courses or the programs, it's just you have to fill it with the people. And I'd just like to quote what I've heard from the CEO of Katharina, I think it was. He said that in China, the most brightest mind wants to go to battery and work with batteries. Whereas in Europe, the brightest minds wants to go and work with finance. So I think that's part of our problem, actually, to make people want to be engineers, that see it's cool. And that then the rest of us need to promote engineers as well. And so I can also mention that we have in our International Scientific Board, Anna Tissot, who is from Vercor, and she told me that they are building this new school for the whole battery value chain, just because they need to educate the workforce. Yeah. So there's a lot of things going on, that's what I want to communicate.
That's good. So there should be more PR in a sense to get more people involved, and to start early as well for perhaps students already in secondary school to say that engineering is cool and related jobs as well. Looking over to you, John, how do you think we can attract more investments? So going from the skills to investments, so more investments in innovative, sustainable technologies, especially in terms of recycling-friendly materials.
Thank you. I mean, there's a few things with it, and I mean, part of it is at the moment, unfortunately, and I think we're seeing it even this week at the political level, there's a lot of focus on, frankly, on infighting and not necessarily I don't want to pick out Germany specifically, but you look at, there won't be a German government in place until April or May next year. I mean, that's not fundamentally serious. And so you've got this situation where everyone in many cases is trying to fix something from 3 to 5 years ago and not looking at a kind of a positive story of everything is looked at from a very negative position of this will cost money or this will be difficult, not how could we achieve it, and these will be things that we can bring with. It's something I often say from our side on the plastics industry, for example, when we're talking about this, we do believe we can hit the 25% target. And I think that's something that often when I talk to OEMs or suppliers into OEMs, they find that it will be difficult. It is not an immediate thing. You may end up losing 3-5 years, but we do think that it is achievable today with the plastics industry, but we do need that bit more certainty. And unfortunately, I think right now the prevailing political winds in Europe are unfortunately very conservative and very inward looking, and in many cases then that does lead to a kind of a negativity around what is possible and what can be achieved. And in many cases that's actually much more negative than it needs to be. It is entirely doable, it is entirely feasible, it is just a matter of making a decision that says, I am making an investment decision that has a 10-year window rather than a 6-month electoral window, which in some cases right now is what we are seeing. And that political courage is often very much needed there. We see that again just on a very practical level with a lot of recycling companies. They're having short-term problems, but their business is overall viable. But there is investments in some cases, again, coming from either plastics companies or OEMs. And suddenly a mechanical recycler that was in trouble 6 months ago now has a 5-year outlook because they're part of a bigger organization, and they can move ahead on the investments they need and get the equipment they need and get going. But you do need to have that mindset that moves it from, and again, not to kind of constantly bring up China as the example, but it is an example, and we're probably going to see something similar in the US with the change in government expected in January, February. You have these cycles and positivity towards investment rather than a kind of a, oh, it will cost money attitude.
Yeah, so changing the narrative from, oh, we don't want to spend money to, oh, we want to invest in the future and, yeah, make it more valuable.
And to move on and be more positive. I mean, again, we've seen it. There's a lot of highly educated people. There's a lot of traditional know-how. I mean, I don't believe, if I look again from the automotive supplier's perspective, that, yes, it will be tricky for a portion of the individuals who are used to, let's say, an ICE engine, if you're an automotive supplier, to retrain that person. But if you're a 40-year-old who has been through an engineering degree, who has that knowledge, it is possible for you. It might not be always easy, it might be slightly different, but unfortunately it's not your grandfather's time of, I joined a job at 15 and I stayed there till I was 75 and nothing ever changed. But you have these people that are highly educated, highly capable, but you need to have an attitude to them that says, we can make you into something new and different at 40 instead of, well, you're done.
Yeah. It's all about the messaging in the end. Yeah. Okay, thank you very much. So to get more a bit of the technological side of it, Ilai, what would you say are the main technological limitations in battery recycling, and how can we design better batteries with recycling in mind?
Well, I would say that the technology today is there. So do we have a hurdle technological-wise? I don't think so. In China, sorry, I have to mention it again, but there is an industry going and that's thriving today. I would say that the main hurdles that we have in Europe are the issues of scaling up, because that's how the real economies of scale happen. Create the lack of knowledge and educated people who are willing to work in this industry, especially when we're talking about recycling. And then batteries, I think, is even more interesting for people because, well, it's maybe not enough, but when we're talking about circularity, I think one part of the issue is people see it as trash management, and it's not the most glamour topic. So also investment and supply chain creation, because I would say that in terms of circularity and battery recycling in Europe, we're maybe 2 generations behind the China. Today we're still working on creating the right supply chains, and also the idea that we need to have supply chains for a certain type of battery. So we can't put the same we can't put LFP and NMC in the same factory, or ideally you want the same type of NMC batteries in the same factory. So today we're still working on creating the supply chains to feed those factories that are not even built yet. And so that's one big hurdle. So to answer the second part of the question on how can we make batteries more easily recyclable is creating those batteries with recycling in mind. So as there's the plastic part of it, creating battery packs that are very easily dismantleable, because that's also one big cost in battery recycling is we recycle the cells but not the whole battery pack. So there's a number of technologies that are currently being built, but streamlining the same battery chemistries, so across a certain industry. So all to create one big supply chain for a certain battery type, not to have different chemistries scattered across the industry. And for example, for battery packs, how can I give an example? Apple lately, in the latest iPhone, they have invented a glue, or maybe they didn't invent it, but they put it in the new iPhone, is a special glue with a rod in it. If you put if you put electricity in that rod, it removes all the glue, and you can dismantle the pack really easily. So that's one type of innovation that has been going on lately. And
I see both of you nodding along. Would you like to intervene?
Yeah, I totally agree with this, that you have to design and plan for the recycling and to make it easy, such as Apple did. And I just wanted to mention the Epiroc company in Sweden. They have making machines for mining. And they have designed now both for recyclability but also for battery swapping. And the thing is that when you start to design not from the way it looks and so on, but for the purpose of sustainability, then it's much easier to make automation of this assembly of the battery, etc. And so that's really what we need to do. Because otherwise the cost of recycling will be too high. And the materials that you get out will make, if you use them in the car will be very expensive at the moment. So, yeah.
So always leaving way for innovation, of course.
Yeah.
Do you also want to comment?
Nothing massive. I think I do see it as one of those areas that we have so far at the legislative side had a lot of negative feedback on that. And that's, again, a very interesting kind of element in terms of which part of the industry are you talking to. And I know that obviously when you're talking about end-of-life vehicles, OEMs remain, but there's always that I always kind of say that a lot of the time when I talk to different people, especially on the plastic side and the design, if I talk to the sustainability person, the design person, and the salesperson, I will get 3 completely different answers, even from within the one company, about what is either possible, desirable, or achievable. And again, it's such a complex area that I think, and of course, if you're talking to the average MEP or to even many member states, there is often that massive confusion there. And again, that's one of the things for us as the plastics industry that we've been trying to go back out and say, this is actually not as difficult as you think it is, but you do need to have a much more open attitude to it. Yeah. Because we can achieve it. And then it's a matter of, instead of sort of starting from a negative position of no, to work backwards. In this case, unsurprisingly, you can imagine I'm usually more aligned to the sustainability person in that trifecta of people. And, you know, we are trying to sort of push that and what can be done, rather than perhaps always the other two characters that are a bit more negative.
So debunking myths, basically. Yeah, we know that well. Yeah, so you mentioned OEMs, which is a good segue. So about creating circular vehicles, another aspect of this session. Linda, how do you include recycled content in vehicles at scale in Europe? And how can we do this without increasing the cost of vehicles while maintaining their safety?
Yeah, it's back to the issue actually about planning for recycling in order to make the recycled material profitable to use. Because if you don't plan for it, and it's very hard to recycle, it will cost a lot, especially if you have manual sorting and things. So we need to plan and design the vehicle. Maybe we should have the engineers have standards for how the batteries should look like, so they'll be easily torn apart. Because if you can, and then if you can recycle them with the good value of the material that comes out at a decent cost, then I don't think there's a problem in integrating them again in the vehicle. And then also, if you look at not just going back to the raw material, but recycling of components and refurbishing of components, that's also doable, especially if you make it into different modules, so module building, so you can remove and replace.
So basically what engineers are at work when they begin a project, one of their first things that they consider is recycling, and what will it have in the long run?
That would be very nice if it was. Yeah. But I must also think in terms of recycling batteries and materials from batteries, that this is long term also, because we're now ramping up with lots of EVs, and these EVs will live for a long time. I think in the session before now, they were talking about 15 years for going down to 80% of state of health for the state of charge for the battery, state of health. So it would be like 15, 20 or plus years before these batteries come back. They will have some second life, and so before they come into the recycling, you can recycle the materials, so to speak, so that it takes time. Yeah.
Great. One last question before I open up to the audience. John, in your presentation, you mentioned something interesting, the value of material. Could you elaborate a bit on this? Like, is it just from a technical point of view, or is it also from a sentimental even point of view?
It's also from a financial point of view. I mean, to some extent, when we talk about plastics, for example, one of the things is, and I have a kind of a personal grudge against this at this point, but you know, the constant reference of everything is a throwaway plastic bottle, or it's a yogurt pot. When you talk about a very highly engineered piece of plastic that goes into a construction pipe, goes into an automotive piece, goes into a medical device, those are materials that have both very high performance value, and in some cases, of course, you don't want it to go, you know, you don't want to replace a car bumper, which has a safety critical element, with something that's of significantly lower quality. But you can maybe take that car bumper and put it into something that's not as safety critical, but it still has a value. Now, that's also a value in terms of the material. It's a value in terms of the CO2. And when we're talking about this from an overall sustainability perspective, that in 10, 20 years, assuming that you take the current projections about climate change, but what we need to do in order to bring the CO2 lower, you know, your choices become either a fairly massive reorganization of how you use and design materials, which in many cases, yes, plastics in some cases have had a slight element of being a little bit too successful. They're cheap, they're moldable, they're cheaper than the alternatives, and therefore, you know, you can use them for everything. And in some cases, that has probably meant that they're used or they're overused and they're treated disposably. We're saying, no, that material still has a value, both in terms of its CO2, but also that you can recycle it, and it can go from being in a car piece to being a filler. It can go from being a very complex thing into being something that you can use for paving. There is other values to it rather than what it has been seen at the moment, where it's often viewed either as just disposable in itself or as something to be used for energy recovery. Now, the energy recovery still has CO2 production. So we're sort of saying, instead of treating this material as something that was created to be used for 6 months, 6 years, 15 years, if you're talking automotive vehicle, automotive plastics, many of them have that 15, 20-year life cycle. But instead of thinking of it at the end of that 20 years as something that's just to be discarded and at best burnt, saying that is something that we can actually take and turn into something else. And for us, that's a big part of the change in mindset that we're trying to push for.
Giving it a new life, then. Great. So now I turn to the audience. Are there any questions? No? Okay. The back. Perhaps we can change the lights because we can't really see much from the audience.
Thank you. Thank you very much. Very interesting. I'm Sébastien. I run a Reliant factory, and we play on the second life batteries. So we set up a factory in Marseille to treat the second life batteries. We have the same difficulties about all the regulation and stuff. And the question is for Ilai. We really believe in the circularity and to avoid all the transport and security stuff for the batteries. So we push a lot about, let's say, the ultra circularity. And we are very interested about the modular factory. And I wanted to know the tons, minimum tons required to set up a mobile factory.
So the mobile factory, I would say the minimum would be 100 tons per year. So you mean the black mass production?
The tons of the batteries you need to be relevant for because we want to, for the moment, for the second life battery, we didn't, we have Veolia in the board. Mm-hmm. And it's very interesting to plug the second life battery to the recycling matters, and we were very interested about the...
Okay, so there's 2 steps. The first step is to take the cells and turn them into black mass, or at least shred them and send them to a battery recycling facility. So for a small scale black mass production, it could be 100 tons per year. If you want to do the full recycling to get battery grade lithium, cobalt, and so on, it would be at least 5,000 tons per year. It really depends on how many steps you're willing to take, and if you, when you stop, and if, for example, if you only do black mass production, you can sell your black mass to a recycler, like Veolia, for example.
Any other questions or comments? No? Okay. Well, then, as a parting question, I wanted to ask you all, what is your main wish, or perhaps takeaway for the audience what they should consider about recycling of vehicles and batteries? What is your message to them?
Ladies first.
Thank you. But my main message is plan and design, and I think that's very important for us in Europe because we want to be self-sufficient of the raw material for batteries, or as self-sufficient as we can be, and in that case, we don't really want to have mines in Europe. We don't want that. At least in Sweden, it's obvious that whenever we find lithium or whatever, there are great protests against mines. And then I think we need to long-term look at recyclability as a way to really get enough raw material. So that way we need to design and plan. Yeah.
if I can add, because you mentioned critical raw materials, I think one important thing is to also treat it as a security matter, not just in the sustainability front. First of all, because when we talk about security, funds are more easily available, and it's increasingly important for Europe to keep those materials in Europe and not be reliant on foreign trade. So, as a conclusion, I think we need to see it as a critical step for our economy, to save our economy, and to not rely on foreign powers to stay safe on the energy front.
Unsurprisingly, I think I agree very much with the previous. I think the main takeaway from my side is a lot of this is very achievable even today. That we have a lot of the capacity, we have a lot of the knowledge. What we lack in some cases is either the political will or a focus on very short-term thinking, that instead of allowing certain companies, particularly recyclers, but you know, again, if I'm talking about my sector, the plastics industry, to give that legislative sustainability criteria guarantees that allow places to make those investments. It's not that the technology or the capacity is beyond us, it's often the political will or the certainty that you start making those investments, you start moving in that direction, and then in 6 months something changes or a government changes and things just fall off the attention, fall off the radar. And I think, you know, we have the knowledge, we have a lot of the people, we have a lot of the technology, we just lack the certainty and the investment certainty for that capacity more a lot of the time. So it is not beyond us here, it's just a matter of having a window that's not 6 months, but maybe 5, 10 years, and to be willing to support it through.
Definitely. Well, thank you very much to this panel and for your valuable inputs. I think, yeah, gave a lot of food for thought for the audience. Yeah, thank you very much.
Thank you.